Let me know when we're on. Was that a yes? Hello. Welcome to the Kansas City Woodworkers Guild. I'm Craig Arnold, the president of the Guild. This is a unique meeting for us being on YouTube. Hopefully we won't have to do this too often, but we see this going on for the next few months. As you can see, I'm wearing a mask, which is a good thing to do when you're at the Guild. But I'm going to take it off so maybe I can talk a little bit better. A couple of things tonight. I'd like to welcome all the new members. If this is your first meeting, you can say hi through the comment section on the YouTube. It takes a few minutes or a few seconds to get the YouTube comment to us, and we'll make sure to say hi back to you. And during our event tonight, if you have any questions, Chris will be monitoring the questions, and he'll be able to ask our presenter when those questions come in. The structure of the night will be, of the meeting tonight will be similar to what we've had in the past, though most of the directors and officers' reports you'll be able to find in the current issue of the newsletter. No show and tell tonight, but next month we are asking that you submit photos of your projects that you've been working on at home and a brief description about them, similar to what we do here at the show and tell, asking what, or we'll be asking what kind of wood it is, what the challenges were, what the finish was, and we'll present those at the YouTube meeting then. And so if you have any questions about that, or if you have any photos you want to send in, you can send them to me at president@kcwg.org, or send your photos and descriptions to kcwg.meetings@gmail.com, and we'll be able to get those on next month's YouTube meeting. So with that, I guess we're going to go to our presentation now. So Rob Young, former president of the Guild, has been a long-time member. He has a new toy that he wants to show off, and he's actually, oh, wait a minute, we forgot one thing. Chuck Saunders has equipment for sale. Come on up, Chuck. I forgot all about that. Sorry. It's not like a normal meeting, is it?
A rigged sale. No one else bid. We're, backwards. Anyway, we have too many wide belt sanders now, so we don't need the Lobo 12-inch wide belt sander. A number of people are interested in that, so we're going to do it on a silent auction. What we'll have a page in the members section of the website, and you can go in and place your bid there. And we'll run that probably till the meeting next month. And high bid will have a new sander.
Thank you very much. Chris did want me to be sure to mention we do have a Facebook page. He's showing that now. Facebook.com/KCWWG, and also on Instagram. KC Woodworkers Guild is the Instagram address there. And that's a great way to share projects that you're doing or ask questions of the rest of the membership as well. But tonight we've got Rob Young, who's a former president of the Guild and also an avid hand tool woodworker. So when I heard he bought one of these, I was like, wow, that's a departure from the norm. But anyway, Rob, thank you for coming and showing off your shaper tonight.
Showing off my shaper, what? No, right, yeah, so it is a hand tool. It is. I mean, come on. Chris, would you start the slideshow for me, please? We got just about 5 slides here. There we go. So, very quickly, what is a shaper origin and why should you care? So, on the left there, you see the shaper origin, and you can see it looks a lot like just a small handheld router. And on the right, you see the big legacy gantry CNC. Now, they're both CNCs, but the shaper is not intended as a replacement for gantry CNC. They do different jobs, mostly. Okay, so we're going to talk a little bit about that. So it's not a replacement for a gantry CNC. So the idea with this little guy is that you can see the animation there there's two stepper motors down in the base, and what you're doing, you're looking down through the shaft of the motor and the collet. And you can see that when those two motors move, it can move the collet through an area about 20 millimeters. So about 3/4 of an inch circle. And then because it also has a camera out in front of it, and if you look in the picture, you can see an example of what the shaper is seeing, it can figure out where it is, okay? And it's got, if you're careful and you follow the instructions and you do everything you're supposed to do, you can come back you can move 4 feet down and come back and be repositioned within about 0.02 of an inch accuracy. If you don't follow the rules, you'll be like 1/16 of an inch off. So it's not perfect, okay? You feed it with standard vector graphic files. Shaper is not in the business of creating CAD or producing CAD software. You're on your own for that. That's very similar to most other gantry systems. So what can you do with it? Well, these are all examples off of Shaper's, from Shaper's customers, and probably the biggest project out there is that music room. And you can search around and find that. And that room is, I think, 16 by 20. And it's a maple floor, and you can see the inlay that's been inserted in there. So as you walk in through the door, if you could read music upside down and backwards, this is some piece of, it's Mozart, but which piece I don't know. But that was all done in place with the shaper. Okay, and then there's some smaller stuff here, and you can even do, you can do jigs, you can build just little oddball things to sit on your desk. And probably one of the neater things I've seen is somebody took and made that skull, and that's just layers of MDF stacked up. So how do we program it? How do we get our files? Well, you do have to do your own CAD. Your CAD can be as simple as just a drawing on a napkin, and then you can mail that napkin off to Shaper, and for an hourly charge they will convert it for you. Like I said, they're not in the business of selling software, so you're better off learning just some degree of CAD. In my case, I'm using Fusion 360, which is an Autodesk product, but you can use SketchUp. The older version of SketchUp, you can trick it into producing an SVG file. If you have the newer Pro version, I think it's built in. You can use Tinkercad, which is an online CAD package. Adobe Illustrator, if you're willing to pay the license fee. Affinity Designer, which is a nice substitute for Adobe. If you're really cheap, you can learn to use Inkscape, which is absolutely free. And if you're really hardcore, an SVG file can be written with a text editor, but I wouldn't recommend it. So you can see sitting there in that screen cap, just a simple two-sided object, trivet, where I've gone and I've shown, all I had to do was just describe what I wanted. I don't have to create any paths, I don't have to do any tooling stuff. It'll just kick it out. So I'm going to do this kind of in fits and starts, but this is what we're going to do. I'm going to show you very briefly a little bit of CAD that you have to do to create your stuff, how you convert it. We're going to show some examples of different materials and things I've cut. We're going to talk a little bit about the bits it uses, and I'll do a couple of brief cuts with it. Honestly, it's not really that exciting to watch somebody cut something with a router, which is what you're doing. That's that. So I will get back to that. If you'll go back to the camera, I'll show a couple of things real quick here, and then we'll go back to the CAD. So when I say it's not a substitute for a gantry style CNC, once you've gotten to where you've got a good file, you're comfortable with your feeds and speeds, and you know it's going to work, you can walk away. You cannot walk away from this guy. You are the motor providing the gross movements, and then it tries to stay within that little corrective area for you. But if you're doing one-offs, if you're doing very large things, for example, the floor, there's no way you could do that in place with pretty much any other tool with the level of accuracy that you get. You can do, for example, hopefully we can hold these up and see them. I don't know if it can zoom in. Actually, I'll just walk up. I'll just walk up in front of it. So this is what we're talking about for inlay. So you would cut, say you're making a real common thing that people are doing with it is those god-awful waterfall live edge tables, right? And they're full of butterflies. Well, if you're tired of the regular butterflies, you either have to cut these out by hand, which if you're in a production environment is not efficient, or you can use the shaper and you would cut this out in one file. And in that same file goes, see, I'm doing this, I'm trying to do this like I'm in a mirror. Use that same file in your receipt, in here, and you cut your socket and you put it in. But what's gonna happen if you cut those two things exactly the same size? It's not going to fit. So that's where this really shines, is as you start cutting that socket, you can cut offsets. You can say, okay, I'm going to bump it out 5/1000ths of an inch, test my fit. I'm going to bump it out another 5/1000ths, test my fit. And eventually you'll get a piston fit out of it. And we'll show, like I said, we'll show a little bit for that. Here's another example of that same sort of process. So if anybody's ever used these sauce hidden hinges, right? So these are the bigger ones. So this would be like for a cabinet door, right? These are a bit tricky to lay out because you have to have a 2-layered pocket. You can see that my pocket is closer to one edge than the other. And even the screw holes have to be in the correct location for these to pop in. And just coincidentally, these are not actual sauce hinges. These are cheap Chinese copies, but it still works with them, and it'll close it up. And I did this before we started tonight, and it took me about 15 minutes to do this from nothing. And if you'll go back to my computer, I'll show you what I'm talking about. That you have to be able to produce. So right here, this is the sauce, hinge. And what you have to do is you have to get the center line of those hinges has to be 55/64ths apart. And you have to be exactly 1/8 inch back, held back from the edge. And it just, all these things, and if you don't get these right, if you have them too close together, obviously the door's not going to work. If you have them too far apart, the door's not going to work. If you don't have them lined up, the depths of the pockets, all that stuff. But all I had to do was bring in that CAD, and away we go. And I can show you. Can you switch to now the camera on my route? There we go. So that's the view on it. So I could go in, and I've got these in, so there's a sauce hinge. So there's my pocket right there. Let me zoom out a little bit. So you can see I place it, that's the inside edge of the hinge. It's referenced to the center line of the hinge. It's got my depths that I need to cut the two pockets. It's got some notes if I want to use the machine, put a engraving bit in and tick where the screws are going to start, or you could go back with a VIX bit and put those in. But once you have that CAD, you can drop those right on there and you're good to go. Let's see, let's go back to the front camera. We'll show a couple other quick things it can do. It's probably one of the coolest things it does, and this is something our legacy can't do yet. I don't know if we're going to upgrade it to do that, but it can't work off its front edge. Okay, this machine with the right kind of jigging, now the legacy could do the same thing, but I could produce box joints with this, and I can put these together in any combination. I don't have to worry about who fit where. I should be doing this up where you can see it. And they'll come together. And it's really probably the neatest thing about being able to do this with this particular equipment is, number one, the software for doing this is built into the machine. I don't have to calculate any of this. All I have to do is tell it the width the number of fingers I'm going to have. It needs to know the thickness of the material because it needs to know some path calculations. But I can tell it exactly how much I want up here. So if you want to do something where you do have an exposed and you round those, you can do it. Otherwise, you can say I'm going to have a 100th of an inch up here, and it'll be a 100th of an inch. And you tell it how much of a gap or how much to leave for glue in between each one, and it'll come out. It's not like when you use the dado stack, and you have to fool around, and you still end up with this quarter of a finger off the end that you've got to deal with. It'll come out, and it'll fit them in there, and they'll be whatever width they need to be to fit 4 fingers, or 8, or 12, or 2, or whatever you want. In fact, we may actually do a really fast example of that. And what else? Another thing a lot of people do with these is engraving. It's really good for sign making. So for example, if you get, let's see, contrast, there we go. So if you get a single stroke font, you can go in with just an engraving bit and hit that. If you have logos, this is for a professor at the university where I work. He's got a company that he wants some stuff engraved on the stands for it, and he sent me these logos. And I don't know if you can see this on this camera, but if you look over here, the star very nearly touches the R, and you lose detail up here in the T and the S and the R where it gets very thin. And that's because in this one it was trying to cut exactly on the line. And then okay, let's try cutting on the other side of the line. Well, it took care of all my detail, but then the kerning is still screwed up. The weight of the R, the spacing, when whoever drew this, drew it on the geometric center of the R, not the weighted center of the R. So it's now too close to the star. But that's something that you can correct. You can either correct it on the machine, or you can correct it in your own CAD package before you cut it. And you're not restricted particularly to, this is aluminum and it's reflecting terribly. There we go. That's aluminum. And you're not restricted to the material you cut. As long as you can get your feeds and speeds right and the right kind of bit, you can engrave or cut whatever you want. Closed-cell foam is a popular thing. So if you want to organize all your tools in your tool bin. I guess I'll pause right there. Do we have any questions yet?
None yet.
Okay. So, what else can you do with it? Okay, so we'll go through a real quick example here. If you'll go back to my computer.
I did have one question.
Okay.
They wanted to know why we were there for lunch, let them know about the LED lights messing with it.
I'm sorry?
Had someone ask why, we weren't doing it up front. And I was
Okay,
gonna let
yeah,
them know
so
the
that
LED
is,
lights.
right, so I'll go through this real quick. This thing has its own camera and lighting system in it, so it has to be able to see out in front of it and to see, and it's a little difficult to see on here, but what it's looking at, to find its position in space, so I keep walking out in front of it, it uses these little, they call them dominoes. So this is a roll of tape with the dominoes on it. And you lay those out in front of you in a plane, and then there's a camera here. The camera can see the base of the unit, and it can see about 11 inches out and 14 inches across. And it's lit with an LED system. Problem is, if you're under some LED lights, you will start getting a beat frequency with the lighting, and it will confuse this thing. So our normal place is to work here in front of the big black screen directly under a set of lights, and guess what happens with this? It loses its mind. So we just turn it around, and I'm actually working in one of the shadowed areas of the shop. That answer the question? Okay. Yeah, that brings up another question that's going to come up is this tape. Obviously, you don't need this on a gantry CNC, because the gantry CNC knows where it is because you've either programmed it manually or you run it out to the stops, and it just knows how to count steps back from there and knows where everything is. This doesn't. The only way it knows where it is with this tape. okay? And so if you're working out in the middle of the floor, you lay out your tape. The tape, by the way, doesn't have to be parallel. They don't have to be perfectly straight. You can have a piece here, and then you can have another piece at an angle like that, another piece over here. You just need to be able to see about a minimum of 7 dominoes within that range. If you see more, it does better. If you don't see enough, it actually tells you, and I'll show that happening. The tape itself is probably the biggest complaint people have, and it's about 150 feet of tape, and it's $18. And people will just say, well, you're going to use it up, and you're going to cost you a fortune in tape, and blah, 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 blah. Well, you know what? You don't actually use that much tape. There are ways to reuse the tape, and it took all of a hot minute for somebody to figure out how to print this tape. So you can actually go online and print sheets of this stuff if you're so inclined. So it's completely a non-issue. That it's just something for people to complain about. Can you pop back to the CAD there, or the PC? All right, so this is just something really silly. I just drew a shape. I put some text on it. I've got a cutout that crosses the edge. I've got, oops, there we go. I've got a pocket of some depth, and I've got, this is actually a hole that goes all the way through, okay? And I did also, in this one, took the text and extruded it in, so the text is actually a hollowed out area. Now I'll show something that happens when you actually start trying to cut these. But this is Fusion 360. You can go in and you just simply say, that's the surface that my machine is gonna see. If you had to do, if you had to have details on both sides, you've got to have a way to register it when you flip it over, and that's fairly simple to do with some registration pins, either in the shape itself or in the jig that holds it to flip it over. And there we go. There's my shape. And I would save it out. I've already saved it, so I'm saving over the top of it. And that's an SVG file. There's a couple different ways to get it onto the machine. You can use, if you've got Wi-Fi available in your house or wherever you're working, you can use the cloud to send it to it. So you can just simply create, if you don't already have a folder, KCWG, like that. I can go in there, I can upload, and I can put that in, where did I put it? As you look at my terrible organization skills, there it is. And there it is, okay? So now it's on it's on a computer somewhere in California. But you can see there's a little cartoon of it right there. So like I said, if you've got a Wi-Fi connection, you can pick it up. So we'll do that real quick. Let me back this up a little bit. All right, so what I'm gonna do, actually I'm gonna go through the whole process. So, and all I've got here, this is, you probably can't see it really well on the camera, but I've got a permanent sheet of the Domino fiducial markers right here. And then I've got various ways to hold work back on my side of it. So what I'm gonna do is, I'm gonna take a piece of just random piece of Baltic birch. I'm gonna double stick it down to a little platform I can adjust in the back. And by the way, you go through a pretty fair amount of double stick tape with this, more so than the marker tape, and don't cheap out on the tape. The stuff I got to use, I experimented with a couple things from the hardware store and some other junk, and honestly that stuff it's terrible. This is a brand called Intertape, and I have absolutely no workable fingernail, and yet I can peel it off. I'm not searching for a knife or something to get it peeled away. And I can stick it down. And here's where some of the stuff really starts paying off. So you can build a jig very, very similar to this, but honestly it's easy enough And I just didn't bring it. I've got one that I built. I just didn't bring it with me. So I'm setting up, I'm registering the top of my work to my dominoes, which also brings up another point. Everything has to be in the same plane, okay? So to get the accuracy out of it, your cutting material, the material you're cutting, and the dominoes that it sees have to be in the same plane. You can't do one of these numbers. Even if you're only off an 1/8 of an inch, a 1/16 of an inch in your heights, it will foul it up because it knows exactly how big these dominoes are supposed to be. And if they're too far away, it simply scales them up, which means it scales up whatever it is you're cutting, and now your sizes and your dimensions are going to be just wrong in there. Okay, so I've got it on a table back here, and it's smooth. So the next thing I'm going to do is I'm going to just start a new project. So I'm going to tell it I'm going to scan. Can you switch to my on camera? Okay, so this is what I'm seeing at the machine. So I'm going to say a new scan. I'm going to start the scan. Now you can see the dominoes there, and you see it as things turn and go from black to blue. It's recognizing them and it's stitching all those together. Now I just said that you need to keep everything in the same plane, but yet I've pulled all the way off, but I didn't, drop down a 1/2 inch. I tried to keep it as level as I could so I could see the material. So it's putting all my stuff together. All right, so there it is. You can see all the little dominoes it found, and then you can see back here's my workpiece on the shelf, and you can see the outline of the workpiece on there. So at this point, I have a couple different ways I could place my my design. So I go in here and I drive around. Let's see, this was the letter K. For some reason, I have a lot of things with S. I have monkeys. All right, so there's the demo disc. Now, ignore for the moment that it came in. It looks upside down, but it's not. That's actually an artifact of the way that crazy SVG gets exported. But I have choices. I can pick my anchor point. So there's my anchor point in the middle. I can rotate it, which again, since it's round, it actually doesn't matter, right? I can play with the scale of it if I wanted to. I could unlock it and change one thing. And here's kind of a cool thing. You'll notice that there's nowhere in here did you see the term mirror. But if I want to mirror this, all I have to do, so right now it says it's 3 inches wide. I change the sign on that. And that's just a rounding error. It actually, that's the other thing. This thing actually works in metric internally. But because I don't completely think in metric yet, I'm working in imperial.
Rob, real quick, I'm going to show your setup.
Okay. Oh, there you go. Yeah, so you can see everything there. So you can see I've got a shelf back behind me. I've got it clamped down to the bench. There's a little arms out here. I can put a secondary shelf to support the weight of it. This thing weighs, I think it's 15 pounds. So you do have to be a little bit careful. Anyway, so the mirroring I did actually mirrored it such that because it's a round object, it doesn't look like I mirrored it. So I guess I should have picked something different to play with that feature. But let me remove it from there and we'll re-import it. All right.
Rob, while you're working on that, we got a couple questions on
right.
YouTube here. Dave wants to know, do you have or use more than the 3 bits it came with?
Yes, I have a lot of bits. In fact, let's pop back to the front camera real quick. So what it comes with is, let me grab a few things to show you. It comes with 3 bits to get you started. So that's the thing, is you can't actually start right out as soon as you get the package from the UPS person. You get an engraving bit, and what is that, a 60-degree bit, right? You get that, and you can use other engraving bits. You're not limited as long as you've got a 1/4-inch shank, an 1/8-inch shank, or an 8mm shank. You're good to go. It comes with a upcut spiral, 2 upcut spiral bits. There's an 1/8-inch upcut spiral with a 1/4-inch shank. Pretty short cutting distance. That's what, a 3/4 inch or slightly under 3/4 inch cutting distance. Again, you can use longer, but when you get to those skinny bits, you're running the risk of breaking the bit off. And it comes with a 1/4 inch, right? But you can go get other bits. For example, you can go on into the interwebs, and you can buy sets of, so you can see these. These range in size from 0.8mm at the smallest to I think that's an 1/8-inch chip breaker at the other end, right? Those are not terribly expensive. These are high-speed steel. They're not. They're treated steel. They're not carbide. But you can also get, full sets of that. That's a 1.5mm bit, so that's basically a 1/16 of an inch. The smallest bits I have are 0.8mm. And believe it or not, I have not yet broken one of those. And it's not for lack of trying. So that's a 32nd of an inch effectively. So that's a 1/64 of an inch internal radius. And so I brought the fish back out, and as you know, you can't easily cut a square corner with a round bit, at least not with the bit cutting this way, right? But you look right there, right there, under my finger. That's from that 0.8mm bit. Now the whole thing was not cut out with the 0.8mm bit. The whole thing was roughed out with the biggest bit that I thought I could use, and then you just progress down. That's why you don't break the bits. Same thing cutting the pocket. It's the reverse process. All right. And you're not locked into using their bits. As I said, you can get, you can spend big money and get a Mana bits. You can spend medium money and get CMT branded bits. You can get bits made of Chinesium, whatever you want. And they're all fine. They all work. All you have to do is change out the collets. So I've got a 1/4 inch collet in there. I've got an 1/8 inch collet, and I've got an 8mm collet. And then if you need to go bigger for larger cuts, where is it? There it is. For example, this is a 1/4 inch shank with a 1/2 inch straight cutter on it, like that. And it's important too that when you get these, if you get a straight cutter, that you get one that's got carbide in the center. Otherwise it can't plunge, and it'll just have to try and burn its way through, and that's not very helpful. Okay, but that's MLCS has a line of bits that do that, and Katana, which is their house brand premium bit, and they're not expensive. I think this is a $9, $8 bit. So if you need to clear out a fairly large pocket, you can switch to something like that. So, did that get it?
Yep. Another question. Kevin wants to know, what is the name of the double stick tape and where is it available?
Right. So the name is Intertape Polymer Group, IPG. There it is, upside down. No, I had it right the first time. Sorry. It's IPG. You're just looking for Intertape, and it comes in 3/4 and 1 inch widths, and you can find it on Amazon. And I think the 3/4 inch rolls are, it's not cheap, don't be shocked, but a 3/4 inch roll is going to cost you around $8
Yep.
for that. But it's great.
When we're
'Cause
done, if you can find
I'll get
me
you
a-
some links.
Yeah, I'll post them down in the description
Yeah.
for everybody.
Because it's, if you've ever tried to cut, you can't, a lot of it you can't rip, and this stuff you can rip. which is a pretty neat trick in and of itself. And yeah, I shopped around. I think I actually got 2 rolls. The last time I bought it, I got 2 rolls for like $10. So that's $5 a roll. That's actually getting pretty reasonable. So, Craig?
Question, when you're doing this, can you go on uneven surfaces and add like pallet wood?
Right, so
Que-
the question is, does your surface that you're cutting on have to be level or uneven? What's going to happen is it's going to know that it's lifted off of a flat surface, okay? So, boy, I hope everything doesn't just fall over here. On the bottom of it, it's hard to see here because I'm now shining a light into the camera. There's a little pressure plate, and it knows when that pressure plate's unsupported, and it will retract a bit. I'll show a couple demonstrations of it retracted a bit. Now, having said that, if you're bored enough and you go to the YouTube channel for Shaper, somebody, as a Halloween gag video, they actually carved a pumpkin with this thing. So they had the round pumpkin and they built a little platform, so this thing was setting flat, and then they'd cut as much as they could, and then they'd move the platform, and then they'd cut as much as they could, and they moved the platform, and they'd cut as much as they could. And besides the fact that it made a real mess, it worked. Right? So, and you can also cut, so again, you have to support the body of the router, but you can cut something down here, right? So when you're building your jigs, if you're not using something like this, if you need to, as long as your bit can reach down there, it doesn't know that that's not zero, that a 1/4 inch below there isn't zero. If you zero out on a 1/4 inch below there, it'll say, okay, I'm gonna cut down there, and away we go. All right, Craig's over there, so that's why I keep doing that. Right, so I'm gonna place it on here. So this is freehand placing. I'm gonna place it upside down just because I really don't care. And there it is. Now it's still asking me things like I can go into a design mode and I can add another circle to it. I can add another rectangle from here for whatever reason to there with an inside radius. And it's flashing this other thing to let me know that I could be intersecting if I'm not careful. I can have an inside rate. So there I've got a radius of 0.22 inches, and it ended up actually turning it inside out. If you want to flip back to my camera, there you go. All you saw was me waving my hands, but it actually, because I told it to do a radius that was actually bigger than the rectangle, it actually flipped it inside out. So you can do some basic CAD if you have to, like if you're gonna. If you need to like inset, let's say you're doing a floor again, I'm using floor as an example, but let's say you've got an embedded outlet that you need to put in a wooden floor, right? So this would be able to, you know that that's just a rectangle, you know what its basic measurement is, you know it just has to be a slip fit, so you measure it, you place that rectangle, you cut it, and you drop it in there, and you're done. You don't have to get out you don't have to get out CAD to do it. All right, so we're gonna go to the cut menu. So you've got the menus down the side, various things. And so over here you can see the different iconography. So I can set, even though I provide most of the motion, I can actually pick, let me roll this guy, sorry if I make anybody seasick here. There we go. I can pick what are called my speeds, and that's my plunge rate and what's called the auto rate, and that's how fast it tries to move the cutter within that big circle that you see right there. So my cutter is the crosshair, and then you have the circle that it works. And you can change these. So if you're gonna, again, depending on what material you're cutting, and you can also change your rotational speed the usual way. There's a little roller switch on the router back in the corner. The router that is supplied with this thing is designed to use, originally they were using DeWalt trim routers. They were bought out, the Shaper was bought out something like a year ago by Festool, actually the parent company of Festool, not Festool themselves. So now the router that's in this is actually based on a Festool router, so they're Festool collets that are in it. It is not a brushless router. It is a brush motor with a speed controller, and so we'll run it with the audio on a little bit, but it screams. The nice thing about that, though, is that you actually get what's called haptic feedback. I'm moving my hands again. Haptic feedback, if for anybody that plays video games and things, that's when your controller shakes or jerks to the side and things like that. You feel it through your hands, and it'll actually tell you that you've got these set wrong. So go ahead and pop back to my screen again. Okay, you're on it. So I can set my depth of cut. I can set, there's some common ones here, and I happen to be working entirely in imperial units. You can switch it over to work in metric. Or, you know, if you want to move back and forth between them, I can come in here and say 2.5, switch it to millimeters, and that's just under 1/2 of an inch, right? So you can play games like that. Let's see, let me get over something. This is the type of cut it's going to try to do. You can cut inside the line, outside the line, on the line. You can do what's called a pocketing cut. And then this thing is called a guide. It's not an actual cut. That allows me to change any other line in here to what's called a guide. And that just means the line remains. I can't cut it, but it can be used to give me visual cues about what I'm doing. Now right now, it wants to try and cut this as a pocket, and this brings up a point. If we go down, I'm going to skip one. If we go to here, that's my bit diameter, right? So I've got a 1/4 inch bit in there now, and hopefully I can do this without knocking the camera around too much. Go ahead and flip to the front again. So I can take it out, and I can swap that. I'm going to swap it for physically a smaller bit. And it's the same old thing. It's a double lock collet. So if you're used to that, it's a 1 wrench system on these. They don't have. You can't use a double wrench on it. Don't lose that, and don't lose your hex key. That's the keys to the kingdom. They took a cue from Shopsmith. Actually, every connector on this guy and on here is whatever this is, a 4mm wrench. Something very important. Got to remember to lock that motor down. It's got a lot of weight to it, but if you're trying to take a heavy cut, it'll actually push that motor up out of there, and this thing won't know it, and you'll have a mess. And don't ask me why I know that. All right. Yes, YouTube's amazing. Go ahead and go back to my camera. There you go. So I just changed it to an 1/8 inch bit. So I'm going to tell it it's an 1/8 inch bit. Now it needs to zero out. It doesn't know the length of the bit because you don't enter that anywhere. So I need to zero it out. And what it's going to do is leave it on there. I'm going to pull back a little bit. Make everybody sick. All right. Go ahead and put it on there. It's cockeyed, but you'll be able to see this happen. So now you can see, here's the top of my router right here. So watch what happens when I tell it to Z-touch with my dry hand. See, it went down until the bit touched, and then it came back up. Now it knows where 0 is, and it knows based on its maximum travel is 1.7 inches. So it's whatever is subtracted, blah, blah, blah. So it now knows that it can take no deeper than it's probably, if I try to tell it to do a 3/4 inch, see, it still thinks it can do a 3/4 inch cut, but if I try to do like a 1 inch deep cut, it'll say, no, you can't do that. That's how much travel you have left is 0.774 inches. Let me get back up here again. Everybody just strap in and take your Dramamine. All right. Go ahead and go back onto the screen again. So that brings up another point. You are in complete control. If I wanted to snap off every bit I had, I could leave that at that max depth of cut and snap them off. Don't do that. The rule of thumb is no more than your bit diameter as your maximum cut depth in any one pass. And that's a function of your material. So on a harder material, it obviously would be less. And this again is where that feedback comes from. As your bit gets duller, you'll feel the router jerking more, and so you'll know your bit is dull or dirty, or you need to take a shallower cut, or you need to change your feeds, or you need to change, if you're getting burning, you need to change your spin rate. So anyway, I've got an 1/8 inch bit now. I'm going to take an 1/8 inch depth of cut. I'm going to go back over this guy. So now you can see before with that bigger bit, it wouldn't show this funny little pocketing pattern because it knew that a 1/4 inch bit can't fit in there. Right now it knows I can fit a 1/4 inch bit. In fact, I could go in and say, cut an inside path, and here, let me get that offset out of this. Now it shows me my what they call the marching ants. So it knows that I'm going to make an inside cut, and it knows now, even though on the first pass of anything you've got a fully trapped bit, so it will jerk more. Subsequent cuts where you have some relief on the other side of the bit, it won't jerk around, but it knows this to make a standard cut. It's not going to make a climb cut. Okay, now you can trick it into making a climb cut, but by default it just simply does everything it can do not to allow you to make climb cuts, which may or may not be a good thing. It really just depends on your material. And then the final one I didn't really touch on is this guy right here. That's my offsets. So right now I have 0 offset, and you can see that it's showing my gray goes right up and touches the green, which means it's going to cut right all the way up to the edge. I can go in and now take a slightly smaller cut. Now, why would you want to do that? Why don't you want to go right up to the edge right away? Well, you don't want to do that because we're using a small handheld router. We're using a small bit. Even though we're taking a light cut, that bit's going to deflect, and you're just not going to have a good time. I'm going to quote South Park, and you're just not going to have a good time. So what you do is you sneak up on it. You cut inside, and you leave yourself about 1/100 of an inch, more or less. Actually, what you want to do is I get smaller bits. I want that to be a smaller number. I never want that number to be more than the radius of the bit. Okay, so definitely 1/100 of an inch is this is like trying to work in a mirror that's not a mirror. Is definitely fine enough, and if any bit deflection occurs, I will take it out on the final pass. All right, so, and then one other thing that popped up here is you see this little guy that says helix. So whenever it knows that it can fit the entire path within the magic circle, so you can see the marching ants now fit entirely within that circle, it will ask you if you want to use what's called helix mode, and that's where it just simply starts and it just drills down. So here in helix mode, I can actually take a deeper cut. I could come all the way down to my final 1/4 inch depth because it will just spiral its way down and make that cut for me. All right. If I, for some reason, didn't want to do that, I can disable that mode. So we're going to go ahead and do a cut. So I'm going to hit you might want to cut the audio. All right, so I'm going to do that again, but with a little bit more offset so the bit will move freely in there, and I'm going to move whoops, that was so much offset it couldn't do it. There we go. All right, so now I can run this actually without turning the motor on, and I'm going to pull this camera back, or you want to pull that guy up. How far can you get? Really what you want to be able to see is the motor just doing a hula dance. So I'm going to try and do that guy. Think you can see it? Yeah, you're going to need to come around, or you know what? Let me just use this camera. That's as wide as you get. You can see the top of my router. You can see it. You'll be able to see it. Switch back to the to mine, and you'll be able to see it. Oh, you can do. Okay, there you go. Picture in picture. Okay, so I'm going to tell it now. Here's something else. It's actually fairly smart. It knows I don't have the motor. You have to switch the router on and off manually, and it'll know that I haven't done that, and it'll say, "Hey, dummy," but I can force it into doing that. Now it's a little hard to see. Yeah, you can't see it in this one. Tell you what, let's do this. Let's get some light on the subject. Flashlight. All right, I'm going to do that again. Let's say cut. Oh yeah, I gotta. It knows also when you're not holding on to it because of that pressure plate, and it knows I don't have the motor running, so I'm going to override it. Yeah, you really can't see that moving around because we can't really get quite the. You can see it in the big camera. So I don't know. Tell you what, just go on YouTube, find it, and there are a lot better examples of that happening than my crappy little example I just did. So anyway, I did an inside cut, right? So now I could come back and tell it to be a 0 offset. Inside cut, 0 offset, 1/8 inch. And now I'm going to do this manually. So go ahead and just stay on this camera, my camera. Let me get back on it here. And you'll be able to hopefully watch the little bouncing dot, because that's what I'm watching. Oh, I'm also watching, by the way, up here. See this little symbol up here? That tells me the number of, it can see more than enough dominoes right now. So if I start blocking that camera, or blocking the number of dominoes, it'll flicker, and if I block enough of them, it's my hand here. So it'll all of a sudden go, so you can still see all the ones down at the base of it. That's more than enough. Now it's saying, hey, you've only got about half as many as you really need. And if it goes red like that, it's warning you, you need to get out of there. And then if I do, it's called an air cut. So you can see this, maybe you'll be able to hear it. So I'll go in and start an air cut. And you see it's trying to follow my line, and it's telling me which way I need to slide. But if, like a jerk, I keep going, it aborts the cut, pulls the bit up, and it tries to protect me. Now, the thing is, it can only pull it up so fast. So if you're being a real jerk and you're going like that, it's not going to save you. You're going to have a ding in your work. All right? So just something to be aware of. Well, let's go back to, we're doing a 1/4 inch. We're going to do our final cleanup pass. So let me put my ears back on. You do need to evacuate the chips, otherwise it'll clog up just like any router. I can also tell it to do it automatically. So I did it first manually to show you that you can just drive it around and do it, but then I can hold that green button, or I can actually go into what's called an auto cut mode, where I can double click that button on the way down so I don't have to keep holding it. And when it's auto cutting, it's moving at that inch per second or inch per minute rate that I programmed and making those corners for me. So when you're doing something intricate, your best bet is to let it feed itself, as long as it can stay in there. In fact, I'll demonstrate that real fast. So here's the result of what we just did. Right there. There it is. Right, and it's where'd you go? Hello. There we go. Like it wasn't hard enough before. There it is. So, and again, it's ply and it's an upcut bit, and it's probably getting to the end of its life, so it's a little fuzzy. You generally want to use an upcut bit if you can, just simply because having that bit choked in its path full of chips is just not good. I'm sure Woodcraft is well stocked with upcut bits because your boss has one. Yeah. So anyway, there's that. So I'm going to swap that bit out, and we're going to put in the engraving bit if it hadn't rolled off onto the floor yet. And I'll show you what that auto cut, what I'm talking about.
Another question is,
Yep.
Is there a free for a hobbyist version of Fusion 360 adequate?
Yes. Okay. So I believe when you buy one of these, you still get a 1 year full license that comes with it. Now I use 360 through work, so I've got no problem with that. If you go to Autodesk's website and you jump through the right hoops, yes, there is a free version to use. It has some features disabled. Most of them have to do with the cam and the rendering side of the package, so that's a non-issue for you. But the free one you have to renew every year, and you have to certify that you're making, that even if you are using it for a business, that you are making less than $100,000 profit off of their software. Shouldn't be a problem for most people. So yes, it is free. But that's the thing, is a lot of other packages will work. There's quite a few free CAD packages out there. And like I said, this thing takes SVG, but if your CAD package can kick out DXF, you're almost there. Those two file formats are very similar, and there are a ton of packages around that will convert one to the other. Or, you know, since you're working pretty much flat, you're doing flat work with this for the most part, if you can use Inkscape and turn on the grid in Inkscape. I keep looking over there like I'm answering the question. So it's yeah, there's tons of stuff. Okay, so I could have cut that circle, I didn't. So I just switched and put the engraving bit in. So I'm going to tell it I've got an engraving bit. It's going to drive down again, and it's working its way down to find the bottom.
It's actually touching on the work.
It's touching off the work, yes. Right, so what it's using is that pressure plate. And as soon as it detects that that pressure plate moved, hey, that's cool. All right, that's better. Oh no, I like the other one. It's doing that. So now, if you'll switch back to my camera again, I'm going to tell it that we're cutting stuff on the line. So when you create these files, you color code the type of cut. And when it came out of Fusion, this is something that's a problem. This is a problem with what Fusion does, is it doesn't get the color codes correct. You do, if you want them to be correct, you need to manually fix them in another package. If, on the other hand, you're using Adobe or Inkscape or Affinity to begin with, you can get the colors correct and it'll have the right cut type from the get-go. But I'm just going to change a couple of these letters real fast here. So it thinks that was supposed to be a pocketing cut, which is dumb. It's an engraving bit. All right, so I'm going to show you what that engraving bit can do if you'll flip back to my camera again. Okay, so again, that was an example of that engraving bit coming through and doing the cuts automatically for me. Okay, you saw it chasing the dot around. It would take this dot and it was just following the letter, the path. Get back on it. There we are. So it would just follow that path around, and you notice it's got the marching. Oh, geez. It's a touchscreen. Yes. It does things. And because that entire E fit within my bigger circle, I could just tell it to auto cut that whole thing and just hold it still. Now, if I wanted to, I could try and follow it around, but you will get a much better result if you let the machine do the quick moves for you. So those inside corners and things like that will come out much cleaner. Ultimately, what you'll end up with after all this fiddling around is this guy, like that. So that actually, I cut that using three bits. So that's that silly little CAD package. You'll notice there's a little bit of burning on the outside. And again, that's because I'm not using a brand new bit for this, because it's plywood, and plywood is a little bit hard on the bits. So I'm using an older bit. But, you know, it's ready to go. And if I calipered that, I'd come out pretty darn close to what I intended.
So the through hole, you have a piece of waste.
Right, so I've got a waster board. Yeah, I've got a backer board. So a lot of times you have to work with a waster, almost always underneath it. Now, because I'm double stuck down, I could cut all the way through it. But if you're cutting something that's fairly large, what's more efficient is to cut, say, halfway through, and then use a bandsaw and a pattern bit. That's a lot more efficient way to do it. Or you can either make tabs in your CAD, or you can do tabs as you're going. So you cut almost all the way through, except for, say, the last 1/10 of an inch. And then you start that last 1/10 of an inch, and you stop periodically, lift the bit, slide over, drop the bit again, and now you've tabbed it, and you're in there. But unless you're going to make just one piece, it's a lot faster to cut it free with the bandsaw. I don't know if we're going to be able to do that. How far could you get to the side with that? Can you see this part? We'll talk a little bit about work holding. If not, we can move the table and can you do it? Can you see all the way down here? Or, tell you what, let's just do this. There. So, what I've got is I've got a flat surface here that I can clamp to, and then I've got, the one I built has two permanently mounted pins, and on this one you can actually roll those pins in flat. But what you can do, there's a cord there, is let's say I wanted to make, we'll go through the box joint real fast, because it just amazes me every time. It works so well. So I can clamp this guy on here. Now I've got a reference right here. It's the same as this. And I need to put my clamps, my work holding clamps need to go in first. Because they slot in from the top. The slots don't go all the way through. Somebody actually thought of that, and that's great, so that when you let go of them, they don't fall on the floor, right? So we clamp this guy here, and these are just sort of arbitrary lengths. I have no idea. How are we doing on time, by the way?
It's a little after 8.
Okay. So I can put the guy in there. I won't even bother cutting it. I'll just go through the setup for it. There we go. And the way these slots are made, if you've got any of the other sort of T-bolt head shaped clamps, they'll fit. These guys fit. The ones that have this shaped head in them, you can slide those in and clamp things with those. So you're not limited. So I've got that in there.
Sure, the festool clamps fit in there too.
Yes. Oh, the thing yes, they'll fit. Yeah, don't lose the keys to the kingdom. Then the other thing I need to do is I need a waster board in there. So I need to take this whole rig out and drop it down. I'll have to realign that piece. And I can put a waster in there that is just a piece of MDF right there. So I wasn't thinking, I need to raise that back up just a bit. So there's nothing stopping you, by the way, from cutting into the aluminum, except you, and remembering what you paid for the damn thing. So, all right, so, and then I can adjust. This is actually, I mean, they thought about this stuff. So the one I built, I'm stuck. If I want these things, if I want my waster to fit tight, I have to shim it with a, like, playing cards or something. This one, they've actually got little cams in there. So now my waster is tight behind it, so I don't get tear out. And then if you don't want tear out in the front, you can either put a piece of blue tape, or if you use a brand new bit, it won't tear out. So there's that, and that piece of material is 3 1/32 long. Okay. So very quickly, I'm going to tell it I've got a new scan. I'm going to see my material. Hello, there you are. So there's my material. I'm going to create a grid. No, I said grid. What's going on here? There we go. Create grid. What have I currently got in there? It's a bit. Oh, I've got my engraving bit. That actually works pretty slick because I can reference the shaft. Yep, I'm on the shaft of it. Or you can flip the bit upside down. And it knows I've got a, let's see, I need a 1/4 inch shaft. So now it knows, I'm going to tell it where the edge of things are. Right there. There. And there. And my grid is, I should have told it to use a smaller spacing, but that doesn't really matter. So now I've got a 1/4 inch grid 0-0'd off the corner of my work. Right there. Right? And then I'm going to say I want to do a box joint. I'm going to use a 1/4 inch bit. I've got, it's slightly less than 1/2 inch, but that's fine. The width of it is, what did I say, 3 and plus 1 divided by 32. So I don't even have to enter it in decimal. Okay. So I say done. And I don't want 10 pins. I want a total, let's say 8 pins, so that'll be 4 in each leg. And for the glue gap, it depends on the material. So like on a hardwood, you want a bigger glue gap than a smaller. So on this one, I can probably get by with 0.006. So you would do one test joint that way. All right. Now I can place the joint. Oops, I shouldn't have done that. Let me remove the joint. And basic box joint. There it is. Now I can place it. There we go. So now what I've got is, I've got the A and B fingers. And so if I were to go start to cut this, and I'm going to do an air cut. So it knows right now that I have to tell I've got a 1/4. Yeah, I'm not going to bother. I don't even have the right bit, so we're just going to air cut this. It now shows me my path that I will take. And so I could start my cut. Obviously I'm not cutting. And that's another cue, by the way, besides the fact that you're not getting any resistance, is it's a lighter colored blue on this one. But then I just keep clearing out my waste. So you can see it went back into the waster board. It comes around. It's like this, like that. It comes back. Now, it has this other return path. I don't have to cut that. The only reason that's there is that any cut path has to be a closed loop. So that's the only reason for that on there. So I'm done with that. And then I could take out my workpiece. I would also probably make it through a couple of depth passes, and depending on the material, I might have cut an offset. But then I would take it out. I don't know why I have that.
Rob, you may have said this already, but when
Flip it
you're
over and do my next one.
cutting and like following the toolpath, how much wiggle room do you have going off that
Right,
off
so
the
that
line?
you've got that circle is about 20 millimeters, so that's 3/4 of an inch, I believe. So that's how much you've got. But what you don't have is if you're getting a lot, let's say you're getting a lot of resistance and you're trying to turn a corner, and all of a sudden you hit a void in your material or something like that, and you slip like that, it's not going to be able to pull that bit back fast enough. Okay, it'll try, but it just can't do it. So you do have to be paying attention to what your material is telling you as you cut to get that. Other questions? You can, oh, here's something else you can do that's really cool with this or any one you build for yourself. It's because I have these reference points here, I can put any other reference against that. So I could put something at an angle, fill it with a wedge, and do an angled tenon. So that's a single angle. If I want to do a compound angle, I could put another wedge behind it and kick it out like that. But the slick part about that is I take that piece out, I put the next piece in, and it's there. And if for some reason I needed to do the complementary angle, I've got that same setup on the other side over here, so I can just move my jig, my wedge pieces over and get the opposite angle.
Windsor chair on a shape.
Russ wants to know,
Yeah.
can you cut dovetails?
You can, but with this thing, it's a parlor trick. So, because a dovetail cutter will undercut. There is a video of somebody doing it. In fact, they actually do an inlaid dovetail. Because you're working with a bit that will undercut your material, so your bit is, your bit is shaped like that, right? So these guys, my fingernails are actually underneath my material cutting. And so if something happens and that thing tries to retract, it'll trash whatever you're working on. You're welcome to do it, but if you go off that path, there's no way to override that feature. It'll yank that sucker right out of there and you're done, right? The other thing that you can cut with, do some really slick things with, is a keyhole bit. Because the keyhole bit cuts on the bottom, the side, the top, and the shank. And so you can actually cut in like a slot. You can use it like a slot cutter with this system and cut for a sliding lid on a box that way. Mr. Hands. What else? Any other crazy questions that people have?
Kevin Thompson wants to know why it's not green festival.
Because it is not Festool. It is not owned by Festool. It is owned by the parent company of Festool. It does. Oh, that actually brings up a point, though. It does ship in a sustainer. So here's something else. If you're in a small shop, that's it. That's all. Well, except for this jig, of course. But that's the footprint of your CNC machine. That's it. So compare that if you're doing mostly flat work or mostly templates. Compare that to, what's the biggest template I can cut? I can cut a template the size of this room if I had to. I could cut a 4x8 sheet. In fact, I was talking to Chuck earlier. There was a request went through the email not too long ago about somebody wanting 5x10 things cut. So a 5x10 gantry router starts at $4,000, right? I've got no problem. As long as I can support the material, I can cut a 5x10 sheet. And I started running the numbers to see, maybe I want to respond to this thing. And by the time I got to $2,000, I quit because I know they're not going to pay it. And the reason is, one of the two key differences are, one, this does not have a live Z on its cut. Okay. Once you set the depth, you're stuck with that for the duration of that cut. So this is really like a 2.5D system. The other thing is somebody's got to be driving it. the entire time it's cutting. It is not automated to that level. So a CNC, gantry CNC is a force multiplier in that sense, that once you've got a good program, you can set that sucker up and just let it run, and it'll make, theoretically, it'll make you money while you're not there. This, you've got to pay some schmo to stand here and drive this thing around. And so even if I paid myself $10 an hour, I ended up way over what anybody would want to pay for those dividers that somebody wanted. But, I could cut 5x10 sheets of acrylic. I could cut 5x10 sheets of ply. It was no problem. Any others?
We've had a couple different questions that refer to does the guild own this? And
Hell no.
yes, it said no. It's Rob's, but you're doing a demo showing us. Then this is a new item onto the market.
Okay, so the logic behind the guild not owning it is find any other machine in here that doesn't have some sort of user-induced damage on it. It's just too likely that somebody would damage it, and then it'd be out of commission as I kick the cord that I've got attached to it. Yeah, that does bring up a point. This is not cheap. You can go get what's a trim router? A trim router costs anywhere from $60 to $150, kind of depending on what you get with it, right? This retail, and you're never going to get a discount on it. So by the time you pay for shipping and insurance and sales tax to your door, this guy and the bits is $2,700. Blew a really big hole in my tool budget for the next 2 years. But compare that to the cost of even a quarter sheet gantry router that is not a piece of junk. And you're at almost the same price. Compare that to a 4x8 sheet capable router and you're ahead. But it depends on what you're going to do with it. Anything else?
I think that's it on the questions.
Okay. We covered a lot of stuff in absolutely no detail. So
Listen, we'll get links for everything.
I'll get links, and really the easiest thing to do is just go to Google and search for Shaper Origin. I think their website is shapertools.com. From there, you can read their instruction manuals. You can read go to their YouTube page or YouTube account, look at all their videos. And they've got what's called the Shaper Hub, where you can actually post projects. So they have paid projects and free projects, and a lot of the free projects are user-made stuff. And some of them are great, and some of them you're like, why? Why? Why are you even bothering?
I think some people just have too much time on their hands, and
Yeah.
they do what they can.
Yeah,
Look what I can do.
Look at this. I mean, there's a project up there now. So Kumiko is the big thing now, right? I've got a set of plans I've started working for the jigs, so I could actually cut out the parts to make the Kumiko jigs, because like one of those angles, the real steep 60 is kind of a trick to cut without hurting yourself. But it's easy to do with this. But there's a project up there where somebody makes a faux Kumiko panel simply by cutting plywood. So it's a single sheet. You don't have all the little joins in there, but it's the same. It's a Hoshino pattern, the one that everybody uses. And that's what he did. So, I don't know, from a foot away you can't tell.
Any other questions there tonight? All right, Rob. Well, thank you very much, as always.
you. Oh, boy.
Your Guild coffee mug. Oh, here we have to. Got it?
It was in front of you. Yeah. Yeah, I've been bringing it in to play with just to get familiar with it, and if anybody has any specific questions, I know John Sloss and I did something with it. He was working on one of his Limbert-inspired beds, and the problem was he needed like 6 more inches of travel than the Legacy has. And if you try to jig that up, you're guaranteed that straight line isn't going to be straight anymore. And so we just set it up out here and set his 2 pieces next to each other, put tape on the piece we're not cutting, and cut it, and then move the tape to the other piece and flip-flopped and just nailed it. Yeah.
He said it was just absolutely perfect when he was
Yeah.
done.
It's just
with it.
crazy what it can, yeah.
Great.
And it didn't require any, the hardest part was figuring out how to hold the work down to the table. That was the hardest part. By the way, he's the, it's because of him I actually have only ever broken one bit. So that's the one broken bit was John. But I broke it, John didn't break it.
All right.
So,
Well, having no more questions, I'm going to turn this around this way.
yep, so you can see
See
the
if we can-
official sign there.
There we go. Got the sign with the fan in there. So you can, this meeting will be housed on YouTube, so you can go back and look at it if there's any other things that you want to review. And also the email addresses and all that will be we'll try to get that in the show notes for this one. But remember, next month, send in your pictures of your projects. We'll do the home show and tell version of this. Give me a good description, and I'll read that out as Chris flies through your pictures. So thank you, Rob, very much.
Thank you.
I learned a lot about this machine I didn't know it could do tonight, so thank you. I appreciate that. And hopefully we'll see you all next month. We'll see you in the shop. Stay safe. Keep all your fingers. Good night.